Hello, I am Hyukjae from Line Plus, and I'm developing Line application in Korea. I want to share my experience of applying machine learning function to Line application today, and the presentation will focus on the development process rather than the detailed technology. So you don't have to be a developer to learn something from my presentation. Here is the agenda for the presentation. The most important part are probably the project example cases and the lessons I've learned from them. As you can see, Line has sticker recommendation, text recognition function, and many machine learning functions are applied. If you look at the actual development of these features, in the process, we need to make decisions related to machine learning. For example, you need to use either deep learning or traditional machine learning. Or you have to choose between server or on-device. Or you have to choose between ready-made or real-time. The features that I've mentioned in Line also had to go through these decision-making processes. Then what is the standard for making these decisions? Well, I can say that this is a case-by-case issue. Maybe it will depend on what kind of goals you have in mind for developing the functions. And to be specific, we have to ask these questions. Is there a privacy issue with the data that you're trying to use? What kind of functions are you going to make with the machine learning, and how accurate should it be? And how fast should the function be responsive? Are the questions you should ask yourself. So let's go back to the issues I've mentioned earlier and apply them. Let's say that if you're using deep learning for the functions that you're developing, the accuracy of the results may be higher, but learning will require a lot of data. And deep learning right now is only available on the server. But if you're training from the server, it's going to be hard to collect the data that's needed because of the privacy issue. And if the function UX cannot keep you waiting for every run, you will have to make the result in advance. So you have to think of many different cases. So in this presentation, I will focus on machine learning on device. There are good presentations in the AI session about server cloud or deep learning. So if you're interested, please watch those videos. So the on-device here refers to a mobile client. Simply put, it's about machine learning from the Android or iOS Line app. So I will share my story about 3 projects at Line. I don't have enough time to tell each in detail, so I will focus mostly on video highlight wizard and give a brief overview of the rest. As you can see here, if you're using your cell phone to film a video, it may be shaky or it may take some time to focus on objects. Or just like the one on the left, there may be cases where you need to cut out some unnecessary parts at the beginning and the end of the video. And I sometimes read online and I see the term too long, didn't read. And similarly, the term too long, didn't watch is used in videos these days. And you probably have all experienced, if the video is too long, you don't watch it entirely, you just skip it through, or you sometimes don't watch the video at all. So maybe this is why Line's timeline story feature has a 15-second time limit. So many people, when they're sharing a video, maybe they think that it would be nice to edit out these useless parts and leave only the key parts. But in fact, video editing is a very annoying task, so they just often send it as is. So the video highlight wizard feature that I created is analyzing the video and automatically creating a summary or a highlight. So the difference between summary and highlight is that, as you can see here, you cut out many parts of the video and making into one, and that's called summary. And having only a key section of the whole video is highlight. To do this video analysis, I got help from an open source library called Hyukjae. However, this Hyukjae library is implemented in C++, so porting with the native code of Android was necessary. So actually, this process took longer time than the actual video analysis. First of all, Hyukjae uses a library called OpenCV. And OpenCV is a popular open source library that helps with image processing. But if you open this SDK, only static library is provided. So in order to get the shared library that we needed, we had to cross-compile the source code. In addition, Hyukjae works by extracting video frames, meaning that it has to extract scenes of the video for analysis. And here, they use FFmpeg. Probably many of you have heard of FFmpeg. It is a well-known video encoding and decoding library. But the problem is that this FFmpeg is H.264 codec. It is commonly used codec of the MP4 video format. But FFmpeg had a patent problem with codec, so we couldn't use it. So as a result, instead of using FFmpeg, we had to use Android's media library to extract video frames. The pre-processing process that I've mentioned earlier will extract all the frames from the video, meaning that it will extract the scenes from the video, and that's when the actual video analysis begins. So let me first explain to you the big overview of the video analysis. If you look at all the video footage from what you have extracted, you will probably see some parts that you don't need. So if you see on the left, there are some cases where it's too shaky or too dark, or if it's too bright, you probably don't need to use these. So removing all these meaningless scenes and leaving only the clear sections as much as possible is the purpose of the video analysis. Then you may wonder why this video analysis is based on elimination. In general, summarizing videos and evaluating the result often comes after identifying the genre of the video. For instance, whether it's a sport or a landscape, and then it subjectively evaluates accordingly. But it's hard to do that kind of complex genre analysis on mobile phones. So this is why the purpose of this project was to make a good video summary by analyzing all kinds of videos on a single objective. So that's why we've taken a very intuitive and easy way of analyzing it. So I'll talk about each step in more detail. First, you have to check the color of each scene. So we find the scenes where the entire screen is in only one color. There are some examples of scenes that are too dark or too bright. Then you have to compare one scene with the next scene and obtain the differential value of the pixel unit. And if you add the differential value to the scene unit, you can measure how much the movement there is on the screen. For instance, if it's too shaky, you can find it. So we're going to find a certain level of shakiness or movement here and try to find the shaking scenes. And we will be able to filter out the useless parts. After that, you will get A and B as remaining scenes. And inside, we will look at the biggest movement in each section, and we will look at the shape and color to cluster to collect similar scenes. So here's A and B, and if you look at the thumbnail of B, you can see that it kind of looks different than the part that's behind it. So by analyzing, you can find out or filter what's different. So you can divide into 1, 2, 3. So those are shots. So 1 to 3 are shots. And after that, in order to make a summary, we're going to have to do more work. So in order to make a summary, we have to also cluster 1, 2, 3 based on color, movement, and shape. And we have to extract the most dynamic part of it, thinking that it's the most important part. But when you first start this process, you are supposed to choose the length that you want. For instance, like 15 seconds or 30 seconds. So we're going to take this length and adjust the length of each of the important parts that we have extracted and then put them together. So we make the summary and like that. And for highlight, it has a lot of shooting sections with the shots, and you take the biggest part as highlight. And in the process, filtering, histogram, and clustering needs to be done. And those tasks are done by APIs provided by OpenCV. So far, I have briefly talked about the technical part of Video Highlight Wizard. Now, I am going to look at some of the requirements when developing. First of all, there should be no privacy issue. So if you didn't analyze the video on your own application, you had to upload all the videos on your phone to the server and then do video analysis on the server. But I mean, it's a little bit too much to upload all the videos in my personal phones in the first place. And another problem is that video analysis itself requires a lot of RAM and CPU resources. So video analysis is usually done on servers, not mobile phones. The previous video analysis process was a filtering-oriented processing, which is light. It was done so that it could meet the requirements. So we made it light as possible. But we couldn't have the phone slowing down or running out of battery just because the user was using this feature. So basically, we had to analyze it only when the user is not using the phone and is charging the phone. And because the results can be made separately for each video, so we have already analyzed them beforehand. And then we've created a function so that it takes the results of each video and use them when necessary. So I told you that earlier that with the result of the video analysis, we're making summary and highlight. In fact, when we first started the project, the goal was to create a summary. But because the summary had to edit multiple sections and create into one video, the multi-section editing UI wasn't easy to implement in a small screen. And since we needed this function for a 15-second long timeline story, we changed this function to highlight extraction, not summary. So as you can see from the actual released function on the right, if you look at the video transmission, you will see a scissors icon. And if you click that icon, you will go into trim section. And this feature automatically recommends where to trim. This feature was released earlier this year in Labs, and you can use it in Labs. So far, I've been talking about Highlight Wizard. And now I'm going to tell you about two other examples. And due to time constraints, I'll just briefly tell you the overview. There is one function called AutoPin Chat. This function is about the chat room list and pinning. So anyone who's ever used a messenger probably had to scroll through to find the chat room they wanted. In particular, there was one case that I found out in the interview that the user had 1,000 friends and they had over 100 chat rooms every day. So they had to go through and try to find the chat room that they wanted every time. So if you look at the top, there's a search function. And this function actually is used a lot to find the chat room that the user wants. But if you look at the sort chat room function, that is a pretty basic function. So this autopin chat function calculates the amount of activity in the chat room and picks a small number of chat rooms that you think are active. And using this red pin that you see in the screen, it locks the important chats. So the activity that I am talking about right now is calculated by focusing on writing rather than reading the message, because you can easily read messages through notifications. And when calculating activity, individual messages are designed to become less and less important over time. This is because it reflects the recent amount of activity that can be felt by the users. So if you ask me what the most important requirement when I was developing this, it was privacy issue. It's because they use a conversation message. As you know, Line sends all messages encrypted through letter sealing. So these functions had to be handled inside the app. And it's also a function that's used in the chat list. So, of course, it's used very often. So the response had to be very fast. Fortunately, the amount of activity in each chat room does not suddenly increase or decrease. So it was possible to create results in advance and use them for a certain period of time and then update the results again. Another important point was that when calculating the activity, the importance of individual messages decreases over time. Then we had to reanalyze the entire message because we had to reflect the importance that changed with each analysis. But it's obviously very inefficient. So we were able to do the incremental processing by dividing the calculation process and storing the interim results until they were important. And then we recycle them every time we analyze them to reflect the importance again. This project actually got changed in the course. At first, we didn't just use the amount of activity, but the time and location of the conversation were taken into consideration. And only a small number of chat rooms, not only a small number, but the entire chat list was used. But after making it, this UX wasn't that effective as I thought. So in order to simplify the function and focus more on the benefits, we fixed a few more most active chats at the top. So this project was supposed to be released in labs. But there's chat folder function and it kind of overlaps. So this function that I developed was not released. Personally, I worked on it really hard, but I'm sad that it didn't get released. Next, in Line Pay, there's a function on the left that recognizes credit cards with the camera. And here, we used an open source library called CardOCR for recognizing credit cards. But at the top, there's the traditional credit cards with numbers embossed. It recognizes that well, but at the bottom, we see more and more of these cards. The numbers are printed on the cards. And it didn't recognize the numbers on those cards. So I solved this problem through CardOCR project. How I solved it was that through OpenCV, I found out the parts that had the number and cut it out. And then we implemented it using the OCR library in Google Mobile Vision to recognize the number in the cuts. So we use CardIO library and the process I developed at the bottom, and we combined those together to recognize both embossed and printed numbers on the credit cards. So in this project, I guess the most important part of this project also was that fast recognition speed was the most important part. The goal was to recognize it up to 200 milliseconds. So with OpenCV, I cut the number out only to speed up this recognition. And second, it had to operate independently within the app without the help of the server. The OCR library of Google Mobile Vision was available to be used offline, so I could use it independently. And lastly, I didn't want the app size to increase when I made this feature. And I got really lucky. The Google Mobile Version library was installed outside the app, not inside the app, through Google Play service. So we were able to keep the size of the app when using this function. And this project also, like other projects, I had to change a little bit in the development course. If you look at wallet side of Line, there is a section called My Card. When I first started OCR card project, the initial target was to include and recognize all kinds of credit cards in the world, including IKEA family cards and Costco membership cards. But the problem was that adding the physical card in My Card online was deleted. So I developed all the card recognition function, but it was kind of useless. But at that time, I got a request from Line Pay team in Taiwan. If you look on the right, this is an image of the card. It was an actual released card in Line Pay in Taiwan. So I told you that this had a problem of not being recognized that well with the printed numbers, but this card was launched by Line, but it was not recognized in Line. So to solve this problem, we changed the purpose of the CardOCR project to recognize these credit cards. So far, we have looked at 3 examples. So if you look closely, there were some common requirements. First of all, we had to deal with privacy-sensitive user data, messages, videos, or credit card numbers. And also, the applied UX required a faster response speed. And we found out that the UX didn't cause much of a problem, even if there was an error in the result value. I only experienced 3 cases, so I can't say that these are always the common requirements, but there were some repetitive ones. So if you are looking at similar requirements when you're working on a new project, why don't you consider on-device machine learning? And finally, this is the lessons that I've learned from the projects that I've talked about and other machine learning projects. First of all, when you're working on a project, you shouldn't just focus on the function that you're creating, but you have to have an overall roadmap of the functions that are related to a broader perspective. For example, let's say that I'm creating a function that's to be used in a chat room, and if that's the case, you have to think about the whole direction of the chat room, because most of the times machine learning function development will take long time. It takes about 2 to 3 months. So if there's a change in the direction of the roadmap, you will have to change the direction for the function of the functions. And if we found a user requirement that's newly appeared, maybe it's best to aim to meet the requirements when developing. So I've talked about CardOCR and Video Highlight Wizard, and I had to meet the specific user requirements during development. And please don't forget that the technology is a means of addressing user needs, not the purpose itself. As a developer, I also make similar mistakes. When there's a new technology that looks really cool, I sometimes want to start using and developing just because I want to try using the technology. But oftentimes, if I do that, the result doesn't look that pretty. So I think it's always good to keep in mind, whenever possible, what are their user needs and what technology are we using to address the user needs. So, if possible, I thought it would be great to have a mediator between the needs of the users and technology. I guess the planners would be the suitable candidates. And when you design machine learning or plan a function using machine learning, you often plan it assuming that the result of machine learning is always a right answer, but actually it will come with some errors, especially for on-device machine learning that's running on mobile phones. It clearly has performance limits, so you have to have a UX that can tolerate the possible errors. For example, in case of CardOCR, we've tried to recognize a card several times, and if you can't recognize it, you will have to provide a UI that allows you to enter the number manually. Or maybe, like a recommendation, you can provide a function, so maybe it doesn't interfere with the user's experience when using the app. In fact, the easiest and the simplest way to apply machine learning is to improve the existing features. I think it is the safest and the easiest way to keep the UX of as-is feature while enhancing performance. But of course, there is a limitation that it cannot provide a new and impactful function. Lastly, I recommend you to use machine learning functions that are supported at the platform level, such as Google ML Kit and Apple Core ML. There are many advantages, but the best thing is that the size of the app doesn't increase as much. Also, consider using an API that helps with background work, like Android Work Manager. This is the end of my presentation, and thank you for listening.